Imagine waking up one morning to headlines claiming that the sun, the blazing heart of our solar system, is slowly cooling down. At first, it sounds impossible. After all, the sun has burned for billions of years, lighting every sunrise, powering Earth's weather, and making life itself possible. How could something so enormous and powerful begin to cool? And if it did, what would that mean for humanity, the planets, and the future of our cosmic neighborhood? The truth is far more fascinating than science fiction. The sun is not a simple ball of fire that burns at a constant temperature. It is a living, dynamic star filled with powerful magnetic fields, violent eruptions, and changing cycles of activity. Scientists constantly observe tiny changes in its brightness, surface temperature, and magnetic behavior to better understand its future. Recent observations have sparked new discussions because certain regions of the sun appear less active during specific periods. Large dark patches called sunspots increase and decrease over an approximately 11-year solar cycle. During quieter phases, the sun produces fewer solar flares and coronal mass ejections. This reduced activity can make parts of the sun's outer atmosphere appear cooler than during periods of intense activity. While these changes are completely normal, they remind researchers that the sun is far more complex than once believed. But does this mean the entire sun is cooling down? Not exactly. Deep inside its core, nuclear fusion continues to transform hydrogen into helium, releasing unimaginable amounts of energy every second. This process has powered the sun for about 4.6 billion years and is expected to continue for roughly another 5 billion years. The sun remains incredibly stable on human timescales, even though its surface constantly changes. Interestingly, astronomers have discovered stars similar to the sun that occasionally enter long periods of reduced activity. One famous example in Earth's history. The sun is more dynamic than it appears. The sun constantly changes through magnetic activity, sunspots, solar flares, and its 11-year solar cycle, making it a highly active and complex star. The sun may look like a steady, unchanging ball of light in the sky, but in reality, it is one of the most dynamic objects in our solar system. Beneath its bright surface, enormous rivers of superheated plasma move constantly, creating powerful magnetic fields that twist, stretch, and sometimes snap with incredible force. These magnetic changes produce spectacular events, such as solar flares and coronal mass ejections, which release vast amounts of energy into space. Scientists also observe dark regions called sunspots, which appear because intense magnetic activity makes those areas slightly cooler than the surrounding surface. The number of sunspots rises and falls in a repeating cycle that lasts about 11 years. During active periods, the sun experiences more eruptions and stronger magnetic storms, while quieter periods bring fewer dramatic events. Despite these regular cycles, the sun remains remarkably stable as a star, continuously producing the energy that supports life on Earth. Advanced space telescopes and solar observatories monitor these changes every day, helping researchers understand how our nearest star behaves. Each new observation reveals that the sun is far more complex than people once imagined. Rather than being a simple, unchanging source of light, it is a constantly evolving star whose activity influences every planet in the solar system. Studying these changes helps scientists better understand not only our sun, but also countless other stars throughout the universe. Why some scientists discuss the sun cooling. During periods of low solar activity, certain regions of the sun become less energetic and appear cooler, but this does not mean the entire sun is losing its heat. When scientists mention that the sun appears to be cooling, the statement can easily be misunderstood. It does not mean the entire sun is rapidly losing its heat or that it is about to stop shining. Instead, researchers are referring to temporary changes in the sun's activity that naturally occur during its solar cycle. Every 11 years or so, the sun moves between periods of high and low magnetic activity. During quieter phases, fewer sunspots appear, solar flares become less frequent, and the outer atmosphere shows reduced levels of energetic activity. Some regions of the sun may even appear slightly cooler than surrounding areas, creating the impression that the sun itself is cooling. However, these variations are normal and have been observed for centuries. They are part of the sun's natural rhythm rather than evidence of a dramatic transformation. Modern spacecraft equipped with advanced instruments carefully measure the sun's temperature, brightness, and magnetic fields to understand these subtle changes. Every new observation helps scientists improve models of how stars function and evolve over time. Although headlines may sound alarming, the reality is much less dramatic. The sun continues to generate immense amounts of energy, and its core remains extremely hot and stable. Understanding the difference between temporary surface changes and the sun's overall stability is essential for appreciating how this extraordinary star truly behaves. Nuclear fusion still powers the sun. Deep inside the sun's core, hydrogen continues to fuse into helium, producing enormous amounts of energy that will keep the sun shining for about another 5 billion years. Deep within the sun lies its core, where one of the most powerful natural processes in the universe takes place every second. Under extreme temperatures of around 15 million degrees Celsius and crushing pressure, hydrogen atoms collide and fuse together to form helium. This process, known as nuclear fusion, releases an enormous amount of energy in the form of light and heat. Every second, the sun converts hundreds of millions of tons of hydrogen into helium, producing the energy that travels across space and reaches Earth about 8 minutes later. This continuous flow of energy warms our planet, drives weather patterns, supports plant growth through photosynthesis, and makes life possible. Although the sun experiences changes on its surface, such as sunspots and solar flares, these events have little effect on the fusion reactions occurring deep inside its core. Scientists have studied the sun for decades and found that its energy production remains remarkably stable over long periods. Based on current understanding of stellar evolution, the sun has enough hydrogen fuel to continue shining for approximately another 5 billion years before it begins the next stage of its life cycle. This incredible stability makes the sun a reliable source of energy for our solar system and provides scientists with valuable insights into how similar stars across the universe are born, evolve, and eventually reach the end of their lifetimes. How changes in solar activity affect Earth. Variations in the sun's activity can influence space weather, satellite operations, communication systems, and may have subtle effects on Earth's climate over long periods. Although the sun is nearly 150 million kilometers away from Earth, changes in its activity can have a noticeable impact on our planet and the technology we depend on every day. During periods of intense solar activity, the sun releases powerful bursts of energy known as solar flares and coronal mass ejections. These eruptions send charged particles racing through space, and when they reach Earth, they can interact with our planet's magnetic field. This interaction creates beautiful auroras near the polar regions, but it can also interfere with satellite operations, GPS navigation, radio communications, and even electrical power grids. For this reason, scientists constantly monitor the sun to provide early warnings of major space weather events. On the other hand, during quieter phases of the solar cycle, the sun produces fewer eruptions and a weaker solar wind. This allows more high-energy cosmic rays from deep space to enter the solar system, which can affect spacecraft and astronauts traveling beyond Earth's protective atmosphere. Researchers also study whether long-term changes in solar activity have subtle influences on Earth's climate. While the sun is only one of many factors that affect global temperatures, understanding its behavior helps scientists build more accurate climate and space weather models. Every new observation strengthens our ability to protect modern technology while expanding our knowledge of the close relationship between Earth and its nearest star. Scientists continue studying the sun to understand its behavior, while its ultimate evolution into a red giant and later a white dwarf remains billions of years in the future. The sun has illuminated our solar system for approximately 4.6 billion years, yet scientists believe its most dramatic changes are still billions of years away. By studying stars that are similar in size and age, astronomers have developed a clear picture of the Sun's long-term evolution. At present, the Sun is a stable main-sequence star, steadily producing energy through nuclear fusion in its core. However, as its hydrogen fuel is gradually consumed over the next 5 billion years, the Sun will begin a remarkable transformation. It will expand into a red giant, growing so large that it is expected to engulf or severely affect the innermost planets, including Mercury and Venus, while dramatically changing conditions throughout the solar system. Eventually, the Sun will shed its outer layers into space, creating a glowing cloud of gas known as a planetary nebula. What remains will be a dense, hot core called a white dwarf, which will slowly cool over billions of years. Although this future is unimaginably distant, scientists continue studying the Sun today because every observation reveals new details about how stars live and evolve. Powerful space telescopes, solar observatories, and advanced computer models allow researchers to explore mysteries that were once impossible to investigate. Each discovery not only deepens our understanding of the Sun, but also helps explain the life cycles of billions of stars scattered across the universe.